Example number 47. Solve the logarithmic equation log x plus 4 to base 10 plus log x plus 16 to base 10 is equals to 1 plus 2 log x to base 10. So what do? You must ensure that you have the same base, isn't it? Base 10, meaning this term must also have log to base 10, isn't it? So what do we have? We have log x plus 4 to base 10 plus log x plus 16 to base 10 to be equals to 1, then you introduce log 10 to base 10. Because a log of a number to the same base is 1, isn't it? Are we together? Then plus 2 log x to base 10. We now have the same base in each and every term. Are we together? For you to have base 10, meaning you must introduce log 10 to base 10, which is 1. So it is like 1 times 1, you just get what you add there, isn't it? Okay? Now the next step is to get rid of that coefficients. To get rid of that. So here we have log to base 10 of x plus 4, then plus log to base 10 of x plus 16. Then this 1 becomes the power, isn't it? Are we together? So there we have log 10 to base 10. 10 raised to power 1 is just 10, isn't it? To power 1, then plus log x squared to base 10. The coefficient becomes the power. Are we together? After that, you make each and every side of the equation one term, isn't it? Isn't it? So we factorize out log to base 10, meaning log to base 10, here we now have x plus 4. Addition changes to multiplication, so that when you take log to base 10 back inside, this multiplication goes back to addition. You see, this is in bracket to mean it is one term, isn't it? And this one is also in bracket to mean it is one term. So the only sign between them is multiplication. Are we together? So that when you take the log inside, multiplication changes back to addition. Reverse process, isn't it? To be equals to 10 raised to power 1 is just 10, isn't it? So the other side of the equation, if you factorize log to base 10 outside, what do you remain with? 10 times x squared. Addition changes to multiplication, isn't it? So when you take the log inside, this multiplication goes back to addition, isn't it? Are we together? Yes. Lots of logarithm. So from there, you can now ignore the log on either side of the equation. You can only ignore the log when you have one term on either side of the equation. Is that okay? So after ignoring the log, what do we remain with? We remain with x. We remain with x plus 4 times x plus 16 to be equals to 10x squared, isn't it? Expand this. What do you get if you expand this side? You get x squared plus 16x plus 4x, that is plus 20. Then 4 times 16 plus 60. 64, isn't it? Is equals to 10x squared. So can you now simplify that? X squared going the other side, you get 9x squared. 10x squared minus x squared is 9x squared, isn't it? Plus 20x going the other side, you have minus 20x. Plus 64 going the other side, you have minus 64 to be equals to 0. We've remained with 0 this side. So equal to 0 that, you can put 0 the other side, isn't it? Quadratic. Use quadratic formula to solve that. What are the values of x using quadratic formula here? A is 9, you can see here clearly A is 9, B is negative 20, C is negative 64. So what are the values of x using quadratic formula? You simply keep what we learned the other day, isn't it? What have you found to be the solutions of x? A is 9, B is negative 20, C is negative 64. What are the solutions? 4. 4 is the first solution. Good.
The second one is negative 16 over 9.
Negative 16 over 9. Then what? Because these logarithms are not absolute value, you ignore the negative solution. Are you seeing that? Are we together? So the only solution is the solution which is positive, because for them, all the solutions of logarithm must be absolute. So these logarithms were not absolute, so you only pick the positive solution. Are we together? So there you get, it implies x is equal to 4. Are we together there?
Yes.
it implies x is equals to 4.